if you remember back when we started doing these equations, the instructions they gave you were to solve by inspection. And I said there will become a time when that will no longer be an option for you, and we have reached that time.
Yes.
No more, children, will you look at an equation and just say, oh, this is what the answer is. You must do this exactly, write it out exactly like I show it. You can't go wrong. It actually makes it easier when you do it because you don't have to try to do so many different steps in your head. But in order to do equations, you have to know a couple of different things. I'm going to grab my little equation thing here. First of all, an equation, ladies and gentlemen, must have an equal sign. In order to have an equation, it comes from this word here. You have to have equal signs. Okay? You have equal signs. There's no other way to have an equation because that's what equation means, it is equal. And there are only, children, there are only 4 different types in a mixture of those. You can either have an addition equation, you can have a subtraction one, maybe you know where I'm going with this one. You can have a multiplication one, and you can have a division one. Although we don't see division quite in the way that we think about it as much as you might think. Okay? Here is the deal. And this is what you need to think about with this. Number one thing you think about is your goal, let me write one down here, can I? Yes, by all means do. If you have x, yeah, I don't like it. I don't like it at all. If you have x plus 6 equals 15, well, let's make it 158. Okay? Your goal is to get the letter x by itself, or whatever letter it is. It doesn't have to be x, but get x by itself. Because once you've done that, then you know what x equals, and that's what you're solving for. You want to know what this number is right here. Okay? And I don't care if you know what that number is now. It doesn't matter to me, because you're going to follow these steps. Yes, Kendall?
That was my question. We had to follow the steps and just do the
No longer will you just write an answer down.
Yeah.
You will follow these steps. Okay? So here's the gist. Okay? Step number 2. Well, we already know this isn't. Number 1 wasn't really a step. It just knows that your goal. Okay? Here is what you need to think about. Whatever type of equation it is, think the opposite. Okay, because you're going to have to do the opposite to solve it. Okay? Now let me give you what that means here. Let's just take this little simple equation here because it's an easy one. This is an addition equation. X, how do I know? There's an addition sign there. Bam! You guys got that already. Okay? So right away, I know to solve this, I am going to subtract because that's the opposite of addition. Okay? I want to get my x by itself. So the way to get rid of what's on the equation with the x, it's the 6. In order to get this x by itself, I have to subtract 6 because 6 minus 6 is nothing. It goes away. And I'm left with just the x. Now, isn't that just a wonderful little thing? Okay? But what you have to understand is this, which is going to be our step number 2, which is why I have this handy dandy little model that doesn't seem to be balanced out here. There it is. Okay, here is the deal. When I started out with my equation, this side equaled this side. They were balanced, like this thing is balanced. okay? But in order to get the x by itself, what did I do? I took 6 away from this side. Well, when you do that, we'll count out 6 here. 1, 2, 3, 4, 5, 6. When you take 6 away from one side, it's no longer balanced and it's not an equation. Until the next step, which is, how would I get this thing to balance back out again? Without adding 6 back to this, because then that wouldn't make any sense, because I'd be back where I started from. What is? I could put 6 back there, but then we've not
Take
accounted.
6 away from the item.
Thank you, Josh, which is our next step here up on the list that says, whatever you do to one side of an equation, you have to do it to the other. So now I take 6 away from this side and my balance isn't very good, but let's pretend like it is. I must be at 6.5 here. This is cheap plastic.
Put them all back in.
Yay! No, it doesn't matter. That's the rule here. That is step number 3. In equations, what you do to one side you have to do to the other. Okay. In other words, I can't stop here by just subtracting 6 over here. When I subtracted 6 from this side, it became unbalanced until I subtracted 6 from this side over here. And 158 minus 6 is 152. Now my x is by itself, I know what x is equal. And I need to see, ladies and gentlemen, all of this. Don't start cutting corners on this because it gets much more complicated. You got to do it on easy stuff in addition to the hard stuff. Okay? Another example of that would be this. What if I have x minus 3.6 equals 8.4? Okay, no longer do you sit there and think in your head, well, what does this have to be, blah, blah, blah. You just look at this and you go, what type of an equation is that? It is a subtraction equation. To solve it, I am going to add 3.6. Because a minus 3.6 and a plus 3.6 goes away because they're opposites. Okay, but the rule is, if I added 3 to this side, I guess I can't really do it there, can I? If I add 3 to this side, in order to get the balance out, I've got to add the same to the other side. Okay, so if I added 3.6 over here, I have to add 3.6 over there. Okay, and your answer is 12.0. Yeah, look at that, isn't that handy? Now don't, well, we got a couple more examples to do. That was an addition one, that is a subtraction one. Here you have x over 8 equals, I don't know, 15. Okay, back in the day, I would tell you, well, just think about an easier one than this and see what process you did that. Well, now you can just go and say, well, what type of equation is this? It's a division one. To get rid of the divided by 8, I actually multiply by 8. Because what happens when I multiply by 8? The 8's cross off, I'm left with just the x. But the rule is, if I multiply one side by 8, it's no longer balanced until I multiply the other side by 8 as well. And you end up with 120. Same thing is true if it's a multiplication equation. Multiplication one just looks like this. 7, let's just put the letter M, equals 147. We don't have to put the multiplication sign, we just assume it's that. This is what I need to see. The opposite of multiplication is division. You divide by 7, that gets the 7s to go away. You're left with a 1, but we don't write that out there. I have to divide this by 7. What does 147 divided by 7 give you? 21. Okay. Always think opposite and do to both sides. There are a couple more rules we'll get to when we get to more complex equations, but for right now. And it doesn't matter children what side the x is on. If I have this, 84 equals x minus 13, okay, it doesn't matter, I can get my x alone on either side of it. What would I do here to get the x by itself? I need to add 13, because this makes this go away, I have x by itself. I add 13 over here, it's 97. 97 equals x is the same thing as x equals 97. It doesn't matter what side of the equal sign it's on, as long as it's by itself, you're going to get that answer there. Kendall?
For that, x over 8, why do we have our time under multiply by 8?
Because what type of an equation is this? This is x divided by 8. What's the opposite of dividing by 8? Multiplying by 8. What's the opposite of multiplying by 7? Dividing by 7. You always do the opposite because it undoes what you have next to that x.
So there's only 4 steps.
There's more, but we gotta get to wait till you get complex one. I got one more big thing. I got one more pretty much bone crushing thing to tell you, but I'm waiting for Taylor to stop looking like she doesn't get something.
Well, I just don't get the multiplication.
Opposite of multiplication is division, and one way to show division is by putting a fraction line and dividing. That's the easiest way to do it here. Okay, 7 divided by 7 is 1. We don't usually put the 1 in front of a number, it's just an assumed one. And 147 divided by 7 is 21. It's just a way to show division.
And then what about the division?
This one?
Yeah.
This was x divided by 8, so I multiply by 8. And when you multiply 8, you make it a fraction because this is a fraction. The 8's cross cancel because it's 8 over 8. It just was going to cross off and multiply that side by 8. It sooner or later will become a no-brainer for you. You'll just see it. Oh, that's it. Alright. Now, special case. Westfall?
You know another additional one?
Another addition one?
Yeah.
You want me to do an addition equation or a subtraction equation that's solved by addition? You give me the for example, throw one out.
X plus 50 equals
15?
50 equals 175.
175? So to get the letter x by itself, what do I have to do? Subtract these 50s, that gives you nothing, you just cross that off, you're left with just this x, and then whatever you do to one side, you have to do to the other. 75 minus 50 is 129. Think opposite. Kendall?
Do we have to make that one fraction?
Yep. You need to have it exactly as I have it right there. Including a square, not a circle. This is stone. I got one more big thing to go, and then you want me to wait there for my big thing, or what's that?
Do your big thing.
Stay for the big
It's
thing.
nothing, it's nothing perfect.
The big thing, children, is what happens when you see this. Here's kind of like a special case thing. If you see something that looks like this, let me do another look so it works out. This usually freaks people out. Now, I could go through the very long explanation about, first of all, what type of an equation is this? Because it still works. It's a multiplication. So you actually divide. And when you divide by a fraction, you multiply by its reciprocal. Skip all of that because this is what I want you to write down. Write this down. Anytime you have a fraction in front of the letter, comma, you flip and multiply both sides. because division, when you do fractions, is the same as multiplying by its reciprocal, you don't have to do all those steps. It will just look like this. If you have a 3/5 in front of the x, you multiply both sides by the reciprocal of 3/5, which is 5/3. Mostly because that's the same thing as dividing by 3/5. But you just skip all that stuff there. If there's a fraction in front of the letter, flip and multiply both sides by that, whatever that thing is. Because what happens here is these cross off, 5 divided by 5 and 3 divided by 5. You're left with just the x. On the other side, multiply across, you get 5/6, and that is your answer. If there's a fraction, that's kind of like the special case. It follows the same rule, except I just skipped you from having to do a whole bunch of odds and ends that would just confuse you.
You said we flip both sides?
No, whatever I do to one side, I do to the other. So if I multiply this side by 5/3, I have to multiply this side by 5/3.
But don't, you said flip both
No,
sides.
flip the left side. Flip the one in front of the x. Flip the fraction. Flip the fraction in front of the x. Flip the one in front of x. Front of x. I will tell you right now, I will ask you this question about 100 times between now and the end of the year. Because it'll come up, somebody will say, I don't know what to do in that fractions in front of the letter, and I'll say, okay. What do you do anytime there's a fraction in front of the letter? Flip and multiply. I can guarantee if you went to the 8th grader and asked them that, maybe they forgot by now.
Where's Jeremy?
Kendall,
So you multiply each side and then add them?
where did I add anything?
Well, like you multiply each side and then you didn't add the one.
What one was there to add?
5.
1 times 5 is 5, 2 times 3 is 6. There's no addition in any of this. This is all multiplication.
Why don't you add the 5/3 times 3/5?
Why don't I add the 5/3 times the 3/5?
Yeah.
Why don't I add them?
Well, isn't it
Well,
one?
that's
Because I'm
one.
multiplying.
Why don't you add
What's 1?
5/3, so there, the
Right.
reciprocal.
1x is the same thing as x.
Oh.
There's no difference between that. We just don't write ones in front of letters.
So if it's like 2 together, you're correct.
There won't be a 2. This will always cross off to give you a 1 or not, or just the letter. Let me give you another example. 7/8 x equals 8. You are going to multiply both sides by 8/7. Whatever this fraction is, you flip and multiply. These will both cross off to give you just the x. And this one over here would end up being 64/7, which I'll just leave as 64/7 because that's the point of what we're doing today. Josh.
I was wondering why don't you, like for the 3/5 x equals 1/2, why don't you make it 2 1s on the other side for 2 1s?
That's why I would.
Well, because you did it on the other side.
No. What did I do to the other side? I multiplied this side by 5/3.
But why don't you multiply that side by 2?
Because it's whatever I do to this side, I have to do to that side.
Oh,
And what I did here was I multiplied by 5/3, so I have to multiply this by 5/3. That's just the way it works. Just accept it and enjoy it, children. Don't question it. Just accept it and enjoy it. Any other questions on that? Don't worry, if you don't get it, you will eventually.